In my last video series on autism and diet, I talked about the benefits of broccoli sprouts, but the most commonly studied nutritional and dietary interventions for autism and diet involve variations of gluten-free and casein-free diets. Where did that even come from? In the 80s, a team of respected Norwegian researchers reported a peculiar finding. They were comparing the urine of autistic children to the urine of normal children in hope of teasing out any differences that could lead to hints as to what the cause is. This is a urine profile, which shows spikes for each of the various components. This is what normal urine comes out like, with the peptides region pretty quiet. Peptides are like small pieces of proteins, and normally we shouldn't be peeing out much protein. But this is the urine profile from a child with autism, with all sorts of peptide spikes. Here's another one. This raised the question, can the pathophysiology, the dysfunction of autism, be explained by the nature of these discovered urine peptides? First, they had to answer, where do the peptides come from? They didn't know. But there was a clue. Most of the parents of autistic kids reported that they got worse when they were exposed to cow's milk. Well, there are these two proteins, gluten, a protein in wheat, and casein, a protein in milk, that break down not only into peptides, but exorphins. Exorphins are opioid peptides derived from food proteins, called exorphins because of their exogenous origin, meaning from outside of the body, and morphine-like activity, as opposed to endorphins, which are morphine-like compounds we produce inside our bodies. So maybe some of these food peptides represent like a new class of hormones. So is that what the kids were peeing out? Apparently so, as some of those peptides had opioid activity. OK, so maybe they were onto something. There are two types of opioids that have been found in milk. One is the casomorphins. In view of their morphine-like activity and their origin, they're breakdown products, fragments of the milk protein casein. What's the other one? The other opioid is the actual opiate morphine. There appears to be actual morphine in milk. This can't just be a coincidence. It's hard to believe that these or other types of opioids found in the milk are devoid of physiological or nutritional significance. And think about it. It makes total sense. Morphine and the opioid peptides may have an important role in the mother-infant bond. We want infants to be addicted to their own mother's milk. OK, but what about the milk of another species? Human breast milk is markedly different from that of other species in that it has the lowest casein content. And human casein is a markedly different protein in terms of its sequence of amino acid building blocks. Human milk has 15 times less casein than bovine milk, and differs sequence-wise by about half, and so breaks down into peptides differently. 21 bioactive peptides have been recovered from cow casein, including multiple casomorphins, compared to only 5 active peptides identified in human milk and only 1 casomorphin. And the casomorphins from bovine casein are more potent. This is a graph of opioid activity where lower means more potent. Here's the potency of straight morphine. And here's bovine casomorphin, significantly more potent than the weak opioid peptide from gluten, which is more comparable to the human casomorphin from breast milk. And indeed, when you expose human nerve tissue to bovine casomorphin, it acts more like morphine than the casomorphin from human breast milk, in terms of epigenetic changes in gene expression, not only providing a molecular rationale for recommending breastfeeding over cow's milk formula, but also providing a possible explanation why casein-free diets have been reported to mitigate some of the symptoms of autism. What's good for the goose may be good for the gander, but what's good for the cow could be harmful to the human.